Good evening. In first part of this, we have already solved first 5 problems. Now we will go with remaining problems. Now we have to calculate the maximum bending moment in the structure below. Now in this, we have to maximum bending moment will occur where we have shear force equal to 0. Now for this one, we have to find first RC. So we have moment about B equal to 0. And then we can have minus RC into 8 plus 30 into 4 minus 10 into 5 into 2.5 minus 5 equal to 0. And from this we will get value of RC, that is reaction at C, and we have that value that is equal to 1.25 kilonewton, but minus. So we have RC 1.25 kilonewton downward. Now if it is downward, so it will be very clear that we have shear force 0 only at point B. And we know moment at C we have 0. So we have bending moment at B maximum, and then we can have this as moment about B, that is equal to minus 5 minus 10 into 5 into 2.5, and it comes minus 130 kilonewton meter. If we will not calculate this reaction, then also we know bending moment at C is 0. So maximum bending moment we will get at B. So 130 kilonewton meter. Option is D. Now determine the moment and the vertical reaction at A. At B, there is an internal hinge. Now if we will calculate total load, then we have this total load at this point 1/2 base into height, and this comes 8 kilonewton, and which will act, this distance will be 2/3 of 2, so this will be 4/3 meters. Now similarly, if we will calculate for this, then we can have 1/2 12 into 3, and then this comes 18 kilonewton, and this will be, this distance we will get it as 1/3 of 3, so 1 meter. Now we will find RC first. So moment about B equal to 0, and we have minus RC into 2 plus 8 into 4/3, and that is equal to 0. And from this we will get RC, that is equal to 16/3, and that will be 5.33 kilonewton. Now if we will apply Fy 0, then we will get Ra minus 18 minus 8 plus 5.33, and that is equal to 0, and therefore we will get Ra as 20.67. Now in the exam you need not require to check it, you can directly go because 20.67 is here only, but you should have confidence about Ra. Now if I will take moment about B equal to 0, then we will have, now I will write this as 20.67, and MA we will consider anti-clockwise. So we have minus MA, then plus 20.67 into 3, and then minus 18 into 2, and that is equal to 0. And from this we will get value of MA, that is equal to 26 kilonewton meter. So option is B. Now determine the vertical reaction at D. So let us, we will consider vertical reaction, that is dy at D and F. So we have, this is, let us Fy. Fy. Now we will take moment about E0, and we will consider a right part of E. A right part of E. And then we have to consider only right part. So we have this will be Fy, which will be at F 16 kilonewton, 4 meters and 4 meters. And then we will get it as minus Fy into 8 plus 16 into 4 equal to 0, and we will get Fy that is equal to 8 kilonewtons. So we have Fy that is equal to 8 kilonewton. Now we will consider moment about C equal to 0, and we will consider a right part of C. And then we can have this as, so we will consider this part. So Fy we have that is 8, then we have here that is 16, then we have this as 4 meters, then we have this again 4 meter, then at 2 meter we have dy at 2 meters, and then we have hinge at C which is 4 meters. And then we will take moment about C0. So we will have minus dy into 4 plus 16 into 10 and minus 8 into 14. That is equal to 0. And from this we will get value of dy, and that value we will get 12 kilonewtons. So we have option is A. dy 10 12 kilonewton and Fy 8 kilonewton. Then we have to find maximum bending moment. Now if we will see this, then we have total load. This will be act which will be half WL, and this will act at L by 3. Now we will find reaction. So moment about, now I will say this as A, this will be B. So moment about B equal to 0, and then we will have RA into 3L minus 1 half W into L into L by 3. And then we will get it as RA that is equal to 1L gets cancelled, and we will have WL square upon 18. Yes, half WL into L by 3, and this comes below, and from this we will get value that is equal to, sorry, we are taking from this side, so this will be 2L by 3 actually. So 2L by 3, and this comes L gets cancel, so WL by 9, and this value comes 0.11 WL, and from this we will get RB Fy0 plus RA minus 0.5 WL equal to 0, because we have this as 0.5 WL, and from this we will get value of RB that is equal to 0.39 WL, and this will be my maximum shear force, because any one of the reaction will be maximum shear force. Now we will go with shear force 0 point, and then we have this value that is W, this is L. And now let us, we will consider we have shear force 0 at X, and this will be Y. Then we can have Y is equal to W by L into X, and shear force 0 that is equal to 0.39 WL. This will be reaction, and then we have minus half X into Y. And then if we will put it, then we have 0.39 WL minus half X, and we have W by L into X, and that is equal to 0. And this W we will have cancelled, and then if we will solve this, then we will have X square equal to 0.39 into 2. 2 goes on this side, L square, and we will get value of x that is equal to 0.88 L. And from this we will get y equal to W by L into 0.88 L, and that will be 0.88 W. And now maximum bending moment we will get, that is equal to, due to reaction we have 0.39 WL into 0.88 L minus, due to this triangle having value 0.88 L, so this will be minus half x, we have 0.88 into L, y we have 0.88 into W, and will be moment we have to take at this point. So we have into 1/3 of 0.88 L, and if you solve this, you will get value that is equal to 0.229 WL square, and therefore we have option that will be A option. Now this is actually related with your third year because you should know for this. Now for triangle, we have W equivalent, that will be W Lx by 3. Now value of W we have rho into G into thickness of slab. So rho we have 2400 into 9.81, and thickness we have 0.12, and we have to divide it by 1000, which will gives us value of W, which will be 2.83 kilonewton meter. Now W equivalent for triangle we have, for triangle, that is equal to W into Lx by 4. Now W we have 2.83 into Lx we have 10 divided by 4. And from this we will get W equivalent, that is equal to 7.08 kilonewton per meter. And now this triangular we have, that means now BC, if I will plot, then we have this BC in this fashion, that is equivalent UDL, and we have this equivalent UDL for BC, that is 7.08. And if I will find reaction RB, so 1 I will say, or 2 I will say, because we have RB as second. So we have RB2 is equal to 7.08 into 10 by 2. This value comes 35.3 kilonewtons. Now for trapezoidal, W equivalent for trapezoidal, that is equal to W Lx by 2 in bracket 1 minus 1 upon 3 into Ly by Lx. This is known as beta actually. Then we have W 2.83, Lx we have 10 by 2 in bracket 1 minus 1 upon 3 into 1.5. And from this we will get W equivalent as 9.43 kilonewton per meter. Now we have, this is 10 meter BC. Now we have this as 15 meters, and then W we have UDL 9.43 kilonewton per meter. So this is 9.43 kilonewton per meter. Now we will have, this will be RB1, and then we have RB1 is equal to 9.43 into 15 by 2, and we will get this value as 70.6 kilonewton. And total load on column RB is equal to RB1 plus RB2, and this will be equal to 70.6 plus 35.3, which will be 105.9 kilonewton, which is option D. So likewise, we have to solve the problems related with NPTEL assignment number 1. So we will stop here only. Thank you.